Look at the question here. Arrange the following in increasing order of their boiling points. Here we need to arrange the three given molecules in increasing their boiling points. First, we are going to write the key concept. So boiling point, always you need to remember the key concept. Boiling point is always directly proportional to molecular weight of the molecule and inversely proportional to the number of branches, means branching. Boiling point is directly proportional to molecular weight and inversely proportional to its branching, right? So we are going to write 1 chloropropane structure. 1 chloropropane, propane means 3 carbons, and at first carbon there is chlorine group CH3 CH2 CH2 Cl. This is 1 chloropropane, and here 2 chloropropane. 2 chloro means chlorine is attached at a second carbon. Here first carbon, this is second, here CH3, and here 1 chlorobutane means 4 carbon CH3 CH2 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 and first carbon Cl, right? So if you take the molecular weight, here 3 carbons 3 carbons 3 carbons, here 4 carbons, right? So this will be the highest boiling point, obviously. So if we give the numbering, a, this one is A and this is B and this is C, so C is going to be the highest boiling point, right? And these two are same, but here there is no branch in A, whereas B is having one branch, right? So branch is inversely proportional to boiling point, so obviously least will be B and next highest will be A. So order will be B, A and C, right? Next one, what is ambident nucleophile? Give an example, right? So ambident nucleophile means obviously the lone pair electron donor will be a nucleophile. Ambident means, dent means, denticity means how many number of atoms are there to donate. Ambi means 2. Suppose if you take example C triple bond N minus, right? So here in this case, carbon atom having a negative charge, which means there is two unpaired electron, means one lone pair, and on the nitrogen is also a lone pair. So in this case, here both nitrogen can donate and as well as this carbon also can donate. So if any molecule or a nucleophile which is having two different donating sites, but it can donate only one at a time, is called ambident nucleophile. Example Cn and SCN and NO2. NO2 is like this, right? So here these are the best examples of ambident nucleophiles. And third one, why tertiary alkyl halides undergo SN1 at faster rate? See, obviously the SN1 reaction, we know that faster SN1 reaction faster in 3 degree tertiary alkyl halide. 3 degree alkyl halide. Here the key concept is SN1 reaction proceeds through a carbocation intermediate. So SN1 proceeds through a carbocation intermediate. This is very important to understand, right? Suppose if you take a primary carbocation CH3CH2 plus, this is a primary carbocation, and if you take, this is a secondary carbocation, and if you take a tertiary CH3C CH3 here, one more CH3 here. So this is primary carbocation, this is secondary and tertiary. Carbocation means it is electron deficient species, and this species is electron deficient, right? So and the CH3 alkyl groups are plus I groups, means electron donating groups, electron releasing sites. So obviously the electron density increases, the stability of carbocation increases. So in presence of plus I groups, the stability of carbocation increases. So more number of plus I groups and the stability of carbocation increases. So the faster rate is in case of 3 degree alkyl halide, because here 3-degree carbocation is forming. So the faster in 3-degree carbocation, then secondary, then primary. So in terms of alkyl halide, you need to write 3-degree alkyl halide gives faster SN1 reaction then compared to SN2, 2-degree alkyl halide then compared to 1-degree alkyl halide. Why? Because it is having a tertiary carbocation. So in presence of less I group increases, so the carbocation stability increases. And the last one, define enantiomers. Define enantiomers. Enantiomers means, enantiomers are the non-superimposable mirror images. Non-superimposable mirror images are called enantiomers, right? So example, so to have the enantiomer, the compound must be a chiral center. What is mean by chiral center? If the carbon atom which is directly attached to 4 different groups of atoms is called chiral center, right? So now this carbon is said to be a chiral. And why? Because this carbon is attached to, this is methyl and this is phenyl group and this is hydrogen and here OH. So this non-superimposable mirror image means I am going to write like this CH3 here C and here H, but here I am going to write OH and here pH, right? So if I am going to lift this molecule, I am going to replace on this carbon. So here OH and here OH is not going to be the same side, right? So non-superimposable mirror images are called enantiomers, right? Okay, thank you.